These notes will encompass radiation and nuclear decay. If you would turn to the next blank right page, we won't be using the left side, so there can be something on the left side. Let's title this Radiation and Nuclear Decay. Again, we're still going to use our Cornell style. So go ahead and make your vertical line. And the first thing you need to know about radiation and nuclear decay are the notations we use. So we have atomic notation. This should be very familiar to you. It's similar to what you used in chemistry. And here's an example. This is the atomic notation for carbon-14. This is the symbol. This is the atomic number. And top number is the atomic mass. The atomic mass is measured in units of AMU, which are atomic mass units. The atomic mass is the number of nucleons. A nucleon is a particle in the nucleus of an atom, and nucleons are either neutrons or protons. The atomic number is essentially the number of protons. Now, you might say, well, how do you find the number of neutrons? You take the atomic mass and you subtract from it the atomic number. In other words, you take the number of nucleons and you subtract from the number of nucleons the nucleons that are protons, and you're left with the nucleons that are neutrons. There are a couple of forces that we deal with in the nucleus. There are 4 fundamental forces in physics, in the universe in fact, and those are the electromagnetic force, the gravitational force, and then the strong and weak nuclear force. I'd like you to research and find out which of the 2, either strong or weak force, holds together the nucleus. Look it up. And which force holds together individual nucleons? Nucleons are made up of quarks, and so the quarks have to be held together with a force. Which force is it? So figure that out, do some research, and bring that back on Thursday. Here's some examples of atomic notation. We've already seen this one. And it is carbon-14. Carbon-14 is an isotope of carbon. It's a form of carbon. What makes this atom carbon? The fact that it has 6 protons. The number of neutrons do not determine what type of atom. They determine what type of isotope. So carbon-14 has got 6 protons, it's got 8 neutrons, and it has 6 electrons. Here's 2 more examples. Do these on your own. And you can pause the video and then check your work. So go ahead and pause it now and then do it and then check your work. I'd like to know, what is the isotope name, how many protons, how many neutrons, and how many electrons for each of these isotopes. Alright, if you've unpaused the video, you'll see that the second isotope is carbon-12. It has 6 protons, 6 neutrons, and 6 electrons. The third isotope is uranium-238. It has 92 protons, 146 neutrons, and 92 electrons. Alright, nuclear reactions. Really, nuclear reactions, there's different forms of nuclear reactions, but the basic definition is any reaction that results in the nucleus being changed. For instance, nuclear decay is a nuclear reaction. Fission is a nuclear reaction, and fusion is a nuclear reaction. What happens during nuclear decay? Bigger atoms, those are atoms with an atomic number greater than or equal to 84, are radioactive. They undergo radioactive decay because they are too large to be stable. The nuclear force holding the nucleons together is not strong enough. Other forces, like the electromagnetic force, pull the nucleus apart. Fission and fusion reactions. Big atoms break into small atoms. This is fission. And small atoms fusing into big atoms. This is fusion. Okay, let's flip over the page. If you're not finished, you can pause the video. Let's talk about the 3 types of radioactive decay on the next right side. This should be one word, by the way. The first type of decay is alpha decay. And the symbol is the Greek symbol alpha. Alpha decay occurs when the atom gives off a helium nucleus. That's an alpha particle. So an alpha particle is equal to a helium nucleus. And this is the symbol for a helium nucleus in the atomic notation. Okay, an example of alpha decay. If you have uranium-238 and it undergoes alpha decay, you end up with some particle plus the alpha particle. You've got to balance both sides. So what plus 2 equals 92? Well, it's 90, of course. So you go to your periodic table and you look up the atomic number 90. And you get thorium. TH is the symbol. So this is thorium. And the atomic mass, what plus 4 equals 238? Well, it's 234. So this is thorium-234. That's what you get when uranium-238 undergoes alpha decay. Next type of radioactive decay is beta decay. Now this is a fancy B, and that's how I was taught to write the Greek symbol beta. This is beta decay. Here's the symbol. And it occurs when a neutron transforms into a proton. And gives off an electron. So a beta particle looks like this. Also, you can represent a beta particle as an electron. It has an atomic mass of 0 atomic mass units, and it has a -1 charge. Here's an example of beta decay. If thorium-234 undergoes beta decay, it ends up with some particle plus a beta particle. So what is this nucleus? Well, what minus 1 is 90? Well, 91. So we get our periodic table out and we look up 91 and we see it's protactinium, Pa. Also, what plus 0 is 234? Well, 234. So this is protactinium-234. Last type of radioactive decay is gamma decay. Here's our symbol. We looked at this symbol before and said that this symbol was the symbol of a photon. And during gamma decay, a photon is given off that's the frequency of a gamma ray. That's what gamma decay is, the giving off of gamma rays. So this occurs when an alpha or beta particle gives off energy. as a gamma ray. Remember, a gamma ray is just a invisible photon of light. It's too high a frequency to see. An example of gamma decay: if you have cobalt-60, cobalt's symbol is CO, if it undergoes beta decay, it also gives off a gamma ray. So it undergoes gamma decay at the same time. And it produces some nucleus plus a beta particle plus a gamma ray, or a gamma particle, a photon of light. So we need to have a balance. So 27 equals what minus 1? Well, 28. Get our periodic table, and we look up 28, and we have nickel, Ni. So nickel is our type of atom, and we have what plus 0 equals 60? Well, 60. And our new nucleus is the nickel nucleus. All right, we're going to flip over to the left side, and I'm going to give you some homework. You're going to take uranium-238, and it's going to undergo a number of radioactive decays, and it's going to end up as lead-206. So I'm going to give you some of these, and I'm going to ask you to write the equations for each type of decay. We're going to start out with alpha, and we have uranium-238, and it undergoes alpha decay. We've already figured this out. It becomes thorium-234, and then the thorium-234 we've already figured out. It undergoes beta decay. And we get protactinium-234. Then the protactinium undergoes beta decay. And we get some new nucleus plus a beta particle. And you need to figure that out. In addition, we have 5 more alpha decays. Need to figure out each one. Then the new nucleus undergoes 2 beta decays. Another alpha decay. 2 more beta decays. And an alpha decay. This last species will give you lead-206. Plus a helium nucleus. All right, so the homework assignment is not only the other things you have, but in your notebook, if you would please finish up these equations and end up with lead-206. One suggestion, use a pencil. Thank you.